I'm guessing a lot of people in this room have some experience with Autopkg. You've probably got Autopkg doing its thing. If you're a Fleet customer, you've got Fleet managing your devices. And somewhere in between them, you're probably manually uploading those packages to Fleet. You're manually creating your policies. You're manually bumping versions every time Chrome updates 6 times a day. And then next week, you do it all over again. By the end of this talk, you're going to have everything that you need to wire Autopkg directly into Fleet so that packages automatically appear in Fleet with policies ready to go and without any manual steps in between. So here's the situation. That's redundant. Let's just skip ahead in the interest of time. So this whole slide's redundant. Sorry. All good. So before I get to the solution, I want to make the case for why you might want to use Autopkg with Fleet, because every time I bring it up, usually someone at Fleet asks me, why not just use Fleet-maintained apps? After all, there's almost 1,000 macOS apps in the Fleet-maintained apps catalog now, which is incredible. Our team that's putting those together is working really hard on making sure it's the most comprehensive app catalog out there, and it's super impressive. And honestly, if Fleet-maintained apps cover your use case, you should absolutely use them. Don't do this. They're easier to set up. They install and uninstall experience. It's all handled for you. Everything updates automatically. It's a great experience. But there are a few reasons why they might not meet everyone's needs. One of them is customization. Fleet-maintained apps ship with a fixed install and uninstall experience, and that's great for most use cases. But if you need a custom pre-install query or a custom install script or a specific uninstall behavior, you can't really get that with Fleet-maintained apps today. Autopkg gives you full control over every step of the process. There's also the release cadence. You may not want to push the latest version of Chrome the moment it drops. You might want to test it. You might want to hold it back for some reason. And with Autopkg, you actually can control that entire process of when that update gets pushed out to your Fleet. There's also the case for internal apps. I think this is probably the biggest one. If you are building internal apps and publishing them to GitHub, Autopkg can consume them very easily. Fleet-maintained apps, your internal apps probably aren't going to get added to that catalog. And there's also coverage gaps. As impressive as the Fleet-maintained app catalog is, no vendor app catalog will ever have every app. It's just not possible. And with Autopkg, if you need an app that doesn't already have a recipe, you can just write your own. It's pretty easy. I'm sure a lot of you in here have written at least one Autopkg recipe at some point. Just show hands. Who's written a recipe? Yeah, so like 2/3 of you. That's great. So Fleet Importer. I wrote it, but it's a community-maintained Autopkg processor. When a recipe runs, Fleet Importer takes the process package and gets everything into Fleet, including the package file, the software entry, the metadata, the icon, and in most cases, it does all this automatically without any additional configuration. And I just want to call out that I do work for Fleet, but this is not an official Fleet product. This started as a personal project for me because I wanted it, and other people started using it, so I moved it to the Autopkg GitHub org. It's actively maintained and community-driven, and I will come back to that at the end. Right now, there's only about 40 recipes in the repo. You'll find a lot of the usual suspects there, like Chrome, Slack, Zoom, 1Password, Visual Studio Code, GitHub Desktop. But there's always room for more. The thing I'm most proud about, though, about Fleet Importer is that it handles 2 very different workflows in a single recipe file. Direct mode is for teams managing Fleet through GitOps, and then GitOps mode is for through ClickOps. GitOps mode is for teams managing Fleet in a Git repo, and you can flip between the 2 modes in your recipe with a single key in your recipe override. Setting up is 4 steps. First, you have to add the repo into your Autopkg configuration. There's also a parent recipe dependencies file to make it really easy to get all of your parent recipe dependencies added. Next, you have to add just 3 credentials: your Fleet API base URL, your API token, and your Fleet ID. Throughout this talk, it's probably going to be referred to as Team ID because the processor was written before Fleet made the change from teams to fleets. And refactoring code to rename a bunch of variables is hard, so if you see Team ID, just pretend it says Fleet. Third, you have to create a recipe override. If you use Autopkg, this should be a very familiar workflow to you. You configure everything about how this recipe behaves for your use case. And then fourth, you just run it. That's it. It just works. TM. So direct mode's the default. There's nothing to enable. If you have those settings configured and you run the recipe, here's what happens. Fleet Importer will call the Fleet API. It'll upload the package, and it'll create or update the software entry in place. And it's idempotent, which means you can run the same recipe repeatedly, and it'll just update the package each time. It's not going to create a bunch of duplicates and cause a whole problem there. That's the entire configuration. Just those three settings. Run any recipe, and the package will appear in your Fleet server. Direct mode's the easiest place to start. If you're just getting into this workflow, or if you're not running GitOps yet, direct mode gets you from 0 to automated updates pretty quickly without any additional infrastructure. GitOps mode, there's a little bit more to set up, but I think it's the cooler mode. You have to make one change in your recipe override to enable GitOps mode, and you just set GitOps mode to true. It's the same recipe file, it's the same override structure, it's just the output is different. So instead of calling the Fleet API directly, Fleet Importer uploads the package to S3, it generates a CloudFront URL, it writes the software entry, including that URL, into a YAML file in your repo, and it opens a pull request. Now, the question I get a lot on this is, why is S3 in the picture? Why aren't we just uploading directly to the Fleet API? And the reason is that Fleet's GitOps sync is very opinionated, and if a software package isn't defined in your repo at the time of a GitOps sync, Fleet will delete that package on the next sync, and then when you go to merge your pull request, your package won't be there, it'll fail. So instead, what we do is we upload the package to S3 and write a CloudFront URL into the software YAML. When the PR merges and Fleet syncs, it reads that YAML, follows the URL, downloads the package, and adds it into the Fleet server. It's important to note that the packages are not served directly to your devices using this S3 bucket and CloudFront URL. It's only used as a staging location to hold those packages until Fleet pulls them in. And then when it comes to writing YAML, the default paths will follow Fleet's standard repo convention, so if that's how your repo is set up, it just works. If your repo structure differs, you can override that in your override and determine where you want all those files to land. And then merging the PR is your approval gate. You get to control when it goes live. And then we have the feature that closes the loop. Once Fleet Importer is getting packages into Fleet, you probably want Fleet to automatically install updates when a device is running an older version, and that's what auto update policies do. You make one addition to your override, you set automatic update to true. When that's done and the recipe runs, Fleet Importer is going to do three things for you automatically. It's going to extract the bundle identifier from the process package. It'll generate an OS query policy that detects any device running a version of that bundle ID that does not match the version you've just uploaded. Lost my place. And then it links that software entry in Fleet, so when a device fails the check, Fleet queues the install. The automatic policy generation works for most apps out of the box that I've tested so far, but if it doesn't, or if you just want to tweak the logic and do something different, again, in your recipe override, you can just write your own query, and it'll take that instead of the automatic one. The policy name will follow a predictable pattern using the name that you set in the recipe override. But of course, you can also customize this in your recipe override as well if you want to follow a different naming convention. The whole idea here is it's got some sensible defaults, but at the end of the day, everything it's doing is very granularly customizable in your recipe overrides. So you can see here down at the bottom, we've got a example of what the automatic policy generator creates for updating apps. One thing I do want to talk about is being very deliberate about when and how you apply automatic updates. You don't just want to turn this on blanket across every application in your fleet. It's a bad idea. The reason is today, Fleet doesn't check whether an app is currently open before running the installer. When a policy triggers and a device is out of date, the package installer is just going to run. And the behavior from there depends upon the package installer itself. Some installers are going to fail, some may force close the app, and some may just silently update the file on disk and wait for the app to relaunch for the changes to take effect on next launch. The important part is Fleet doesn't really manage that aspect. It just triggers the install. The behavior is up to the developer of that package. Now, for a lot of apps, that's completely fine. Things like background agents, security tools, monitoring software, utilities users don't have open all day, anything users don't interact directly with day in, day out. Great candidates, run the updates automatically. It's awesome. But for things like Slack, Chrome, Zoom, and Teams, apps where someone might be in a meeting or have unsaved work or just something that's going to piss them off if you close it in the middle of their workday, a surprise mid-session install can mean an interrupted call, lost work, or a very frustrated user. So my strong recommendation here is to start with a canary team, pick a small group, enable auto updates for the apps you want to test, and watch what actually happens before rolling it out broadly. Fleet's self-service feature is also a good option for getting users to update those apps without having to force it on them. So definitely think about this on a per app basis. Not everything should be automatic. So now that we understand how Fleet Importer works, let's take a quick look at what a recipe looks like. The first section contains the basic settings of the recipe. The name is the software title as it appears in Fleet, and it's also used to construct the auto update policy name if you enable one. The next keys for self-service, automatic install, and automatic updates are 3 independent Fleet behavior tags. They're just a Boolean true or false. They pretty much do what it says on the tin. I think we can all figure out what's going on there. Categories just control how the app is organized in Fleet's software catalog. Every recipe is going to ship with a default category, but again, you can override this in your override. If you want to override Fleet Importer's automatic icon extraction, you can actually provide a path to an icon yourself here. But again, I found in most cases the automatic process works great. There's some more customization here. Everything in this is optional. You don't have to do anything. You can leave them empty, and Fleet Importer will use sensible defaults. Install script and uninstall script, again, they do what they say on the tin. They let you replace the default install and uninstall behavior in Fleet entirely, and you can put custom logic in there if your package alone doesn't do what you want it to do. Pre-install query is an OS query statement that runs before installation, and if it returns any results, the install is skipped. This can be really useful for checking if like an app is running before you install it, so you can actually build in some deeper logic to check to make sure Chrome's running before updating it, which is pretty cool. Automatic update policy query. This is the field from the auto update policies I was talking about earlier. This is where you can override that if you don't want to use the built-in automatic generation. And then we have labels include any and labels exclude any, which let you scope this particular package to a specific label within your Fleet. And if you leave those blank, it'll just go to everything in the Fleet. And finally, we have some GitOps specific stuff, which is really only relevant if you're running in GitOps mode. GitOps mode is the switch. Again, it's a Boolean, false for ClickOps, true for GitOps. Set it once, and you're good to go. Then these next 5 fields tell Fleet Importer where to write things in your repo. You can see here these are the defaults based on Fleet's recommended repo structure. But again, if you're using your own custom structure, just change these to whatever you need. Where are we? Last one, S3 retention version controls how many old packages to keep in S3 after a new one is uploaded. And this is just to prevent your S3 bucket from getting huge and costing you a ton of money. If you leave it set to 0, it'll never delete anything. So don't do that. I recommend setting it to 1, and then you're only keeping the latest version. So like I said before, this is a community project. I wrote the thing, and I'm the kind of main person keeping this up to date, but I really want this to be a community effort. Adding a recipe is probably the lowest friction open source contribution you can make. I welcome anyone who wants to use this to write recipes and add them to the repo. I will happily merge that pull request. If you've written an auto package recipe before, you already know what to do. It's very easy. If you hit a bug or an edge case in Fleet Importer, open an issue or send a pull request. Happy to figure it out myself or merge your code if you already know the answer. The processor is in Python. It's very easy to read, very easy to work on. And the best place to chat about this is either in the auto package or the Fleet channel in the MacAdmin Slack. Show of hands, is anyone here not a member of the Mac Admin Slack? Awesome. For those of you following along at home, nobody raised their hand. You can also reach out through GitHub. Either way, if you want to add a recipe or have an idea for improving the processor, I would like to hear from you. That's it. There's where you can find the repo. There's how you can add it to your Autopkg workflow.